everyone. By the time others join and we start with the next topic, bell drive. Yesterday in this question, there was some error. Nobody pointed out. What is force torque upon omega?
Ma'am, torque upon radius.
Radius, yeah, nobody pointed this out. I continue to write like this. And I wanted to correct this in front of you. So this was the torque for the gear, 91 Newton meter. This was correct. And then FT for gear. FT for gear. This is this torque for the gear that we have calculated upon radius of the gear, where radius of gear is known 62 or something, and FT for gear, this comes out to be how much? 1.46, I guess. Right, Shravya?
Yes, ma'am.
Yeah, which is also the axial force for worm, 1.46 Newton. Then the tangential force for worm, this depends upon the input torque, and the input torque upon the radius of the worm, or the design power upon Vp, and this value was how much? This came out to be
299.3 Newton.
Yes. So this Ft here was this torque, input torque upon the radius of the worm. Radius of the worm is known. This came out to be around 299 newtons. And this radial force for the worm and the gear in this radial force using the formula for Fr in terms of Ft omega cos theta cos lambda sin theta. This value comes out to be 0.38 kilonewton, right? What was this value?
Yes, ma'am.
Something 380 newtons.
386.29.
Okay, 386. So this is 1.46, which is the only force responsible for power transmission. And this is the axial force for the gear, which is tangential for the worm. This is 299, and this radial force is 386 Newton. So this calculation is important because this would be required again during bearing design. So all of you are again requested to complete this part of the calculation. I'll close this screen and I'll start with the bell drive topic. So what are bell drives? When do you use a bell drive? Nipun, use for speed reduction. It's again a power transmission element between two shafts. Normally when the shafts are placed at sufficient distance away, and instead of using a gear and an entire gear train, it is better to use a belt drive. So belt drive applications are essentially when, yes, for low cost, for long distance power transmission. And this is a friction drive. So this is, unlike the positive drive, this is a friction drive. There are different types of belt drives you have studied. So belt drives, they are essentially called as friction drive because the power is transmitted by the virtue of friction. If there is no friction, then the power transmission will not be possible. You can see this is the belt and these are the pulleys. This is known as an open belt drive. This is known as a cross belt drive, where between the two pulleys, the belt is in cross position. What would be the major difference? When do you go from open belt to cross belt? Yes. When do you go from open belt to, yes, rotation of the direction. In case of open belt, both the pulleys or both the shafts, they are rotating in same direction. But if you want them to rotate in opposite direction, then we go with the cross belt arrangement. And so the belts will cross. If this is rotating in clockwise direction, this will rotate in anti-clockwise direction. What is the material of the belt? What is this belt made up of? So there are different materials available. Mostly the belts are made up of leather. Depending upon the application and the usage, they can also be made out of synthetic fiber. A good mix of rubber plus cotton fiber. This reduces the cost. Normally the speed range for which the belt drive is used is limited to 15 to 25 meter per second. If it's higher than this, belt drives are not preferred, will not give the required efficiency. We'll quickly go through advantages and limitations of belt drive. Let us compare it with a gear drive. What is the basic advantage? Some of you already gave me low starting torque, low cost, speed reduction. Yes. The basic advantage is ease of manufacturing over gears, cutting a gear profile with an involute tooth, 25 teeth, 70 teeth, 54 teeth, whatever, that becomes quite complicated. This is very easy to manufacture. Again, compared to gear drive, where the center distance has to be very precise, there is an ease of installation here. Little variation in length of the belt and the distance can be adjusted, and so variation in center distance, this is allowed, which is not true in case of gear drive. Little variation in center distance is allowed. Another advantage, this is a better option for long distance power transmission. Better than gear drive, because gear train would be always a costly affair. Another advantage, yes, we need economical, yes, this is cost effective. What else? This is a flexible drive as against gear drive, which are rigid drives. This is flexible. You can work with different speeds. The pulleys are available with stepped pulleys. So you have different diameter pulleys, and so we can run with different speed. Yes, noise is less as compared to gear drive. Less noisy, unless it is rotating at a very high speed. At high speed, it will create some noise, some fluttering of the belt. Yeah, disadvantages. Can you list out the disadvantages? The major disadvantages. Yeah, more space. Slip. Slip is a major disadvantage because it is a non-positive drive. It is a friction drive. So slip is a major disadvantage, because of which it's not the efficiency which is low, but it is the power transmission capacity is small as compared to gear drive. Power transmission capacity is less. It is highly inefficient for short distance. If the distance between the pulleys is less, it is not recommended. So if the distance is small, even if you want to go for a cost efficient solution, you cannot use a belt drive. So not recommended for what else? Short distance. What about the life of belt drive as compared to gear drive? Which one would have a longer life, a gear or a belt? Short life. As compared to gear drive, this will have a shorter life. Chances of failure of belt is higher as compared to gear. Less reliable for very high velocity ratio, you can say. So this is again not recommended for high velocity ratios. Normally here the velocity ratio would be in order of 3, 4, not more than that. Another major limitation. Gears can be used for high temperature application also. This is not recommended for high temperature. It's not recommended. So that is another major disadvantage of a belt drive. So how this belt drive works? Yeah, initial tension is required. Yes, this is another major point which we missed out. You are right, Vineet. Without initial tension, this belt will not work, which is not required for chain drive or for gear drive. Initial tension is required. Not suitable for wet environment. Yes, not suitable for high temperature. Not suitable for wet environment. This is also correct. So good balance, 8 advantages and 8 limitations. So let's move ahead with belt drive applications. So before we actually start with the design of belt drive, we have to establish few parameters. You have already studied about the ratio of belt tension. Have to derive the expression for ratio of belt tension in Tom 1. Yes or no? Yes. Okay. So you know the ratio of belt tension. So if this is a driver pulley and this is a driven pulley, and if this is the belt, the way it is rotating, suppose a driver pulley is rotating in clockwise direction, while the pulley is rotating, because of the friction between them, the pulley is pulling this belt, and while creating this pull, there is a tight side tension which is created here because of this driver pulley. And here it has to deliver the belt. It has to let this belt pass through this on the other side. So here there is a pull, and here while pushing, this slack side is created on the driver pulley. And hence, if it is rotating in clockwise direction, this side is known as a tight side tension and this is known as the slack side tension. And this is the driven pulley placed at sufficient distance depending upon what is the kind of application. So initially there is a initial tension, belt tension, what we call as Ti. Gradually on the tight side, with more and more number of rotation, there is a small pull on this side and the tension on this tight side increases. Tension on the slack side reduces. And this process continues till we finally settle down or we reach a static equilibrium position where the tight side tension is T1 and the slack side tension is T2. And if the coefficient of friction between the belt and the pulley is mu and the angle of overlap of the belt at the pulley, this is given by theta, what is the ratio of belt tensions? T1 by T2 given as what is the ratio of belt tension? Arshini? Shivam? E raised to mu theta upon sine alpha. What is this alpha? Pradyuman, what is alpha? It's for the V belt. We are talking about flat belt. So this is equal to E raised to mu theta. Yeah, so we are discussing flat belts. We are not considering alpha here. So the ratio of belt tension is E raised to mu theta. And what is the effective pull? The effective pull of the belt is difference between the tensions T1 minus T2, and the power which will be transmitted will be this effective pull or the difference between the belt tension into its peripheral velocity. Now the power transmission would be more if the difference between T1 and T2 is more. if T1 minus T2 is more, the value of power transmission, this will increase. So can you go on increasing this Ti plus del T by 2 to any extent so that T1 increases? Because with the increase in T, power also increases. Or there is some limitation to this, to what is the maximum value of T1? What do you say? No. There is no limitation. You can increase the value of T1 to any extent. Saurabh?
I want to say, ma'am, that there is a limitation. We can't extend up to a certain limit.
Yeah, and what is that limitation? What limits the maximum belt tension?
Means where it get flexible, much
Sorry?
flexible.
Yeah,
Means-
depends upon the strength of the belt. So this tension T1, it must be less than the strength of the material and the cross-section area. So the tension T1 cannot exceed its strength. So depending upon what is the material we are selecting and what is the cross-section area of the belt, this T1 should always be less than this. Otherwise, if you go on increasing T1 because you want to increase P, the belt would fail. There would be a material failure. Similarly, if you want to increase power, can you simply go on increasing VP? If VP increases, power increases. So if you want to increase the power transmission, can you simply go on increasing this power, VP, peripheral velocity? No. Why? Would that slip because of increase in the peripheral velocity? That is a secondary reason. What is the primary reason? Fluttering of belt. Okay. What else? Friction increases with speed, no? Heat. Okay, another parameter. Centrifugal reason. Perfect. Since pulley is rotating and belt is overlapping this pulley, we cannot increase VP beyond a given reason because then the centrifugal force will increase. And with the increase in centrifugal force, centrifugal tension in the belt would increase. So actually, this material S0 into A, which is limiting its pull, this will be sum of the maximum belt tension plus the centrifugal tension which this belt is experiencing, plus there is one more tension in the belt. Can you tell me what is this third tension in the belt? There is one more tension. One is the tension on the tight side because of this rotation of the pulley. Second is the centrifugal tension by virtue of its speed. There is one more tension in the belt. And what is that? Due to weight? Not exactly. As compared to its tension, its weight is very less. Anybody? The third tension is the tension due to bending. Bending tension. The belt has to bend over this pulley. Smaller the diameter of the pulley, more severe is the bend. Larger is the diameter of the pulley, it is less severe. So there is a bending tension also, and this bending tension is because of the wrapping of the belt. So this is the tension due to tight side. This is the centrifugal tension due to its velocity, and this is the bending tension due to the wrapping of the belt. We call it bending tension. So due to which the maximum tight side tension T1 is limited to AS naught minus TC minus TB. So if you want to increase T1, either you have to increase S naught of the material, or you select a material such that this was strong enough. You have to reduce TC, and for reducing the TC, the value of Vp should be low, and the moment the value of Vp goes down, the power transmission capacity also goes down. So you have to continuously maintain a balance between what should be the velocity, so that the power is just sufficient. We'll have a term, the maximum velocity for effective power transmission. And what is this TC, centrifugal tension? In terms of its velocity, what is the expression for centrifugal tension or centrifugal force? Yes? Vinny, Prajwal, what is the formula for centrifugal tension? mv square. It's mv square by r, but we'll normally consider mass per unit length. Mass per unit length, and so the formula is mv square. So as the value of V goes up, the value of Tc increases, and this mass per unit length has its density into area into V square. This is Tc. And if we rewrite the expression for power transmission, which is T1 minus T2 e raised to mu theta, if I consider this ratio, is this I'm writing? T1 minus T2 into Vp. If I am considering this ratio T1 by T2 as K, can I write down this as K minus 1 by K into Vp, where K is the ratio of belt tensions. So I am further rewriting this expression of power as K minus 1 by K. So for a given belt pulley combination, this K will remain constant because coefficient of friction for a belt and pulley material remains the same. Angle of overlap theta for a given diameter of pulley would remain the same, and so this K is constant. Into T1 to Vp. Now we have just written this T1 as AS naught minus TC minus TB. Normally for flat belt, this bending tension is neglected. This tension is small for flat belt. We'll consider this for V belt. This is equated to 0 for flat belt, and so for flat belt design, we'll not be considering this. We'll consider the value of TB for V belt. And So T1 can be written further as A minus 1 by K. T1 is A S naught minus rho A V square into V. Which is, I can again take this A common. S naught minus rho V square into V. Now you see this value of V, this velocity here is a negative term and here it is multiplying. So if I go on increasing the velocity V, power should increase, but this V square term, this will also increase. And with increase in V, this term will become smaller and smaller because this is negative. And so if a graph is plotted between the power transmission and velocity, this is the power transmission versus velocity. For initial period of velocity increase, the power increases and later this power will decrease. So this is the maximum power, P max. For this region, it is this peripheral velocity which is dominating, and for the second half of this curve, it is the rho v square which is dominating. So with further increase in velocity, this rho v square drastically increases because this is square of v and then the power transmission capacity will go down. And so we will always design a belt for maximum power transmission. We'll always try to get the velocity in this range so that the power transmission is maximum. What about this ratio K? What happens with increase in K? If the value of K in the same formula, we are trying to study what is the effect of velocity and power transmission, what is the effect of material on power transmission. What if the value of K increases? Power will increase or reduce? Power will also increase. So with the increase in K, the power transmission capacity increases, but this will depend upon the coefficient of friction. Increase in value of K will depend upon what is the value of mu. Since K is e raised to mu theta, with the increase in mu, value of PR will also increase. So normally for the leather belt, the value of leather belt, which are most commonly used belts, the value of mu is limited to 0.3 to 0.35. For further increasing the value of mu, it is specially coated. So with the coating and the type of the coating, the value of mu can be further increased. And for the V belt, what is the difference between a flat belt and V belt? What is the difference between flat belt and V belt? Cross section of what? Belt or pulley? What is different? Belt cross section is different. pulley is same, both. For a flat belt, if this is the cross section, for a V belt, the cross section changes. And similarly, for the belt also, the cross section changes. Yes, it is trapezoidal cross section. And if this angle is taken as 2 alpha, then this value of T1 by T2, this is e raised to mu theta by sine alpha. If you consider this as alpha, this is alpha by 2. You have to be careful there. Or instead of writing mu sine alpha, in few books you would find mu dash, where mu dash is mu upon sine alpha. Now if the two belts, if the two pulleys are made out of different materials, if this is the smaller pulley and this is the larger pulley, sorry for this bad drawing. If this angle of overlap is theta 1, this is theta 2. Say the materials are also different. So the coefficient of friction would be same even if the belt material is same, because the pulley is different, so value of mu would change. So belt tensions here at the smaller pulley would be e raised to mu 1 theta 1, and here it would be mu raised to e raised to mu 2 theta 2. So even if the material of pulley is same, mu 1 and mu 2 would be same, but theta 1 and theta 2 would be definitely different. Which one should we select for power transmission? Theta 1 or theta 2? The smaller one or the larger one? Power transmission is based on the smaller of the overlap or the larger one, theta 1 or theta 2? Smaller. Why? If the value of theta is larger, the T1 by T2 is larger, and if K is larger, the value of P would increase. Why do we go with smaller? Your answer is right. We consider the smaller of two, but why? Slip occurs on smaller. Slip depends upon the friction between the two. Design consideration, failure, yes. The worst case scenario is in case of smaller theta. For smaller theta, the power transmission is less, the area is more. So we are always considering for the smaller theta. This is from the safety consideration. And what are the values for theta 1 and theta 2? Bending is also more in case of the smaller pulley. If the diameters are D1 and D2, and if the center distance is C, what is theta 1 and what is theta 2? I hope this is already derived in theory of machines 1. This will be the overlap here. The larger pulley, the overlap is larger. Here, if I consider this angle as some angle phi, then this sine phi is d2 minus d1 by 2c. This diameter minus this diameter upon 2, so it is radius upon this center distance, and so this theta 1 is normally 180 minus 2 times of d2 minus d1 by 2c, and theta 2 is pi plus d2 minus d1 by 2c, or it is c. So this is normally pi minus 2 phi, and this is pi plus 2 phi. Phi or alpha, whatever angle we consider. And so, with the increase in the center distance, the value of theta would increase and the power transmission capacity also increases. If you go for a smaller center distance, then the power transmission capacity reduces, and hence it is more effective in case of larger center distance. One last term is creep, and then we'll stop. What do you understand by creep in the belt? Saurabh?
Ma'am, if we left sometime stressed, then it will deform permanently. Then it is called
Is
creep.
that creep in belt? Is that how creep in the belt is defined? Prajwal? Amey? How do you define creep? Shravya? Under constant load, permanent set, concentrated force. This is not creep. Yeah, you are defining creep with time, which happens in, say, turbine blade. Continuous loading for a long time leads to deformation, but creep in belt is different. Yes, it is irregular expansion and contraction of the belt. So near the belt, near the pulley, this belt is getting stretched over here, and then here it is getting compressed. Again it is stretched and it is compressed. In between the two pulleys, it is having its normal length. So this alternate compression, extension and compression of belt, this leads to change in its modulus of elasticity. So, and ultimately it leads to failure. So creep in belt is due to continuous extension and compression of the belt. If there is a question asked in interview, define creep. Your first question should be, is it creep in general for a machine component, or is it creep of belt? So the moment you ask this question, the interviewer knows you know the answer. So I repeat, creep in any other machine component other than belt is deformation with time, temperature and loading. Normally with high temperature, the creep phenomena, which is the failure because of continuous loading over a long period of time, would increase. Temperature plays an important role in creep failure. Creep in belt is because of alternate extension and compression of belt that the belt fails. That is creep in belt. We'll continue with this topic again in the next class. We'll close here. You are free to ask questions if you have any.
Ma'am, difference between plane and V belt is not clear.
Yeah, we are going to V belt again. अभी यहाँ पर what we have seen is it's only the cross section of the belt which changes. We'll talk about how the power transmission in the V belt changes, how the efficiency in the V belt changes. So that part we'll take up again. For now, we have only discussed that the cross section of V belt is different from flat belt.
Okay.
Anything else? Okay, so we are meeting again on this Saturday. Thank you, all of you.